Janica's channel. For this video, we'll be solving different differential calculus problems involving trigonometric function, logarithmic function, exponential function, and of course, the maxima and minima. So for our first problem, the differential calculus problem involving trigonometric functions. So we have here the first question or the first problem. Find the derivative of y is equal to sine 2x plus cos squared x.
So the first thing we have to do before solving the derivative of the equation, we must first simplify the equation so it will be easier for us to solve for the derivative later. That according to the double angle formula, sine 2x is equivalent to 2 sine x cos x. And we just have to split cos squared x by cos x and cos x. Cos x times cos x. So y prime is equal to 2 sine x cos x plus cos x and cos x. So now we have here the equation that we will going to derive. To solve this first term, which is 2 sine x cos x, we are going to use the product rule, which meant derivative f times g is equal to f times derivative of g over dx plus g times derivative of f times dx. So our f is the 2 sine x and our g is the cos x. So 2 sine x, we have first put the f, which is the 2 sine x. 2 sine x. Then the derivative of g over dx, the derivative of cos x. So the derivative of cos x is, negative sine x. So this is the derivative of cos x. We just have to put the g prime here, which is negative sine x, plus our g, which is the cos x, and multiply it again with the derivative of f. So 2 sine x. So the f prime or the derivative of 2 sine x is 2 cos x. 2 multiplied by 2 cos x. So we will proceed the cos x later. We must first find the first part. Here, derivative of this first part. So 2 sine x times negative sine x is negative 2 sine squared x plus cos x times 2 cos x will have 2 cos squared x. So now we have the derivative of the first part. Now let's proceed for the second part, which is cos x times cos x. Cos x times cos x.
We're going to use the product rule. So f is cos x. And our g is cos x as well. And our f prime, remember that the derivative of cos x is negative sine x. Since they are both the same, we also have the same derivative, negative sine x. Just have to place the values of the variables. So first you have to write the f, which is the cos x. Then multiply it by the derivative of g over dx, which is negative sine x. Put the addition and then g, which is cos x, and its derivative as well, which is negative sine x, the derivative of f. Multiply. Negative cos x times negative sine x is equal to negative sine x cos x plus negative sine x cos x. So now that we have the derivative of both parts, both terms, we're going to put them together based on the first equation we have. So we have y prime, since the derivative of 2 sine x cos x is this one, we'll put negative 2 sine squared x plus 2 cos squared x plus the derivative of cos x, which is negative sine x cos x plus negative sine x cos x. So just have to combine like terms. Negative 2 sine squared x plus 2 cos squared x. And adding same sign, we'll have negative 2 sine x plus x. It's also acceptable as a solution. However, we can still simplify this answer using the trigonometric identity. First, we have to find, since as you can see, we have 2 here on sine squared x and cos squared x. So we can get their common, which is 2. That would leave us with cos squared x minus sine squared x times 2 sine x cos x. According to the double angle formula, trigonometric identity, cos squared x minus sine squared x is equivalent to cos 2x, according to the double angle formula. And 2 sine x cos x is also equivalent to the double angle formula of sine 2x. And now we have the derivative of the trigonometric function. This is our final answer. Now we are on our second problem, the derivative of logarithmic functions. So we have here our problem. Find the first derivative of the equation f of x of the function f of x equal to 5 minus 3x squared but power raised to the power of 7 times square root of 6x squared plus 8x minus 12. So before you're going to find the derivative, you must apply natural logarithms to the equation. So now we have ln 5 minus 3x squared raised to the power of 7 plus ln square root of 6x squared plus 8x minus 12. According to the property of logarithms, we are going to get the exponent by multiplying and transferring it to the term. So we're going to multiply 7 ln 5 minus 3x squared plus, remember that square root means the power of 1/2. ln 6x squared plus 8x minus 12 raised to 1/2. Just like what we did in the first term, you will also put the exponent. Term 7 ln 5 minus 3x squared plus 1/2 ln 6x squared plus 8x minus 12. So using this function, this equation, we will now find the derivative of this function. So using the implicit differentiation to differentiate both sides with respect to x. So with the implicit differentiation, f prime or the derivative of f of x over f of x. So we just have to put 7 times and the derivative of the term, which is 5 minus 3x squared. So remember that we have a constant here, which is 5, and the derivative of a constant is equal to 0. And the derivative of negative 3x squared multiply constant of negative 3 by its exponent will have negative 3 times 2, negative 6x, and power 2 minus 1, since the logarithms have a property of exponent n minus 1, we will have an exponent of 1 over f of x, which is the term 5 minus 3x squared plus 1/2 times the derivative of 6x squared plus 8x minus 12. So just what we did, the first term, 6x squared, going to find the derivative by multiplying the 6 by its exponents. We have 12x, 2 minus 1, that will leave us with a exponent of 1. And 8x have the derivative of 8. And the f of x or the term, which is 6x squared plus 8x minus 12. Next thing we're going to do is to multiply the whole number by the numerator. So 7 times negative 6x have negative 42x over 5 minus 3x squared plus 1/2 times 12x have 6x and 1/2 times 8 have 4 over 6x squared plus 8x minus. Now we have the derivative. So we have solved for the derivative. We are now going to plug the function, which is the first function. So we are going to plug f of x and the derivative, which is negative 42x over 5 minus 3x squared. So remember that we are only looking for the first derivative. Over 6x squared plus 8x minus 12. So what is the value of our f of x? It's here. What is our first value of f of x? Is 5 minus 3x squared raised to 7 power of 6x squared plus 8x minus 12. And our derivative negative 42x over 5 minus 3x squared plus 6x plus 4 over 6x squared plus 8x minus 12.
And that is our final answer.
Now, we are on our third problem, which is the derivative of exponential function. Find the derivative of y equal to ln 2x over e raised to 2x plus 2. We can get the derivative of this function using the quotient formula or the derivative of a quotient. So, according to the quotient formula, we have d over dx, or the derivative of f over g, is equal to g times the derivative of f over dx minus f, the derivative of g over dx over g squared. So, we must first find the value of these variables. So, we have g of e raised to 2x plus 2, and we have f of ln 2x. Now, we are going to find the derivative of f and the derivative of g, or the g prime and the f prime. So, the g prime. According to the exponential property, in looking for the derivative of exponential function, we have a formula on finding the derivative of e u times d over dx. Which means we have u, which is the power of 2x, let's put e, 2x, and the derivative of u over dx. So the derivative of 2x is 2. So now we have the derivative of, or the g prime, which is 2e raised to 2x. So that is the g prime. And now we're going to look for the f prime, or the derivative of f. So applying natural logarithms, we have ln 2 plus ln x. So according to the finding the derivative of exponential function or the logarithmic function, we have ln u, derivative of ln u is equal to 1 over u times the derivative of u over dx. So we have the u, which is the 2. So we have 1 over 2, and the derivative. Remember that the derivative of a constant without a variable is 0. So the answer for ln 2 is 0. So you don't necessarily have to put 0. And ln x, 1 over u, we have the u of x over its derivative of x is 1. So we have 1 over x. So that is our f prime, the 1 over x. G, which is e raised to 2x times the derivative, or the f prime, 1 over x minus f, we have f of ln 2x times the derivative of g, which is 2e raised to 2x over g squared. We have g of e raised to 2x plus 2. Okay, we have 2 here. So now we are going to simplify. And to tidy up the equation, we must multiply both sides, the up and down, by x. So we will cancel this. We have e raised to 2x plus 2 minus 2e raised to 2x times x, because we have our x here, and the ln 2x. And we have x times e raised to 2x plus 2. Just have to simplify the equation. E raised to 2x plus 2 minus 2e 2x x times ln 2x over x e 2x plus 2. So what we have here is the derivative of our exponential function of ln 2x over e raised to 2x plus 2. So this is our final answer, our solution. We have the fourth problem for today's video. It involves maxima and minima. Involving maxima and minima. A fencing is limited to 30 feet. What is the maximum rectangular area that can be fenced in using two perpendicular corner sides of an existing wall? So, what we are going to find here is the maximum rectangular area that can be fenced with just using 30 feet fencing. To solving maxima and minima problems is to draw a figure and indicate the unknown parts by variable. So, according to the problem, there are two existing perpendicular corner sides of an existing wall. So this is the two perpendicular corner sides. This is the perpendicular corner side of an existing wall. So this is a wall, an existing wall. The place where we need to fence is this part, also a perpendicular corner side. This is the part where we need to fence with just 30 feet. Since this is a rectangular area, according to the problem, we have length times width as the dimensions. So let's put this part as L for the length and this as the width. So remember that the fencing is only limited to 30 feet. So this and this part is equal to 30 feet. Thus, length plus width is equal to 30 feet. From this equation, we can find the value of the width. Width is equal to 30. Just have to transfer out. Now change its signs, leaving us with 30 minus L. And also, according to the problem, we are finding for the rectangular area. And of course, we will be using the area formula. So that is for the third step, finding the formula relating the variables. So the formula is area is equals to length times width. That is the formula of the rectangle. Is express the dependent variable in terms of a single variable, the independent variable. So we have the value of v, which is 30 minus L. So we have area. Our area is our dependent variable. And our independent variable would be on the right side, length. We have to substitute the value of v, which is 30 minus L. And just L times 30, 30L, minus L times L, L squared. Now, next thing we have to do is to differentiate the dependent variable in terms of the independent variable. So, derivative of A is equal to 30 derivative of L. And as using the power formula, we will now have 2L derivative of L. You will divide both sides by dl with respect to L. Both sides by dl, since we are differentiating the dependent by the independent variable. So, differential of area with respect to L is equal to 30 minus 2L. We are going to equate the derivative to 0 to find the critical numbers. So this derivative, you're going to equate this to 0. 0. Just have to copy the right side. We will transfer 2L to solve for L. We are going to divide both sides by 2, so that will leave us with L itself. So L is 15. L is the length. So now we have the value of length, which is 15, right? So we have to write the equation length plus width is equal to 30. Remember that we now have the value of the length, which is 15. 15, and the width is still unknown, and it is what we are looking for. So we just have to write the variable w, c is 30. I'm going to transfer 15, w is equal to 30, transfer 15, changing the sign, and that will be us with 30 minus 15. And now we have the width, which is also 15 feet. Remember that we are looking for the maximum rectangular area. So we're looking for the area using the dimensions of length and width. Now let's go back with the formula for area of the rectangle, which is A is equal to length times width. We have the length of 15 and a width of 15. And that will give us an area of 225 square feet. So that is the maximum. What is the maximum rectangular area that can be fenced just using 30 feet fencing materials?